In this module, we will cover 3 separate but foundational topics that will help you better understand the monitoring modules later in the course. These topics include fortification standards, vitamin and mineral premix, and laboratories.
First, we'll start with fortification standards. Standards are published documents that outline specifications and procedures which should be undertaken to ensure a high-quality product that is safe, reliable, and true to the claims on the packaging. Standards can be prepared at different levels: international, regional, national, or local level. In the majority of cases, a national fortification standard is written by a government agency, such as the Bureau of Standards. A fortification standard can be voluntary or mandatory. For countries that adopt mandatory fortification through legislation, adhering to the fortification standard is compulsory for all mills that are expected to fortify, both in-country and those exporting flour to the country. It is recommended for countries to adopt the fortification standard as a legal document that is separate from the fortification legislation. This is preferable over embedding the standard into the legislation. If amendments are needed after the program has commenced, it will be much easier to change the fortification standard in comparison to the legislation. The often emphasized specifications of the fortification standard include the micronutrients that will be added to flour as fortificants, the iron compound that will be used, if applicable, the formulation of the vitamins and minerals, known as the premix, and the amount of each micronutrient expected to be present in flour at the production level, ideally presented as a target average and the acceptable range of variation. The target level for each micronutrient is formulated taking into account the following: the nutrient needs of the target population, such as women of childbearing age, and for the flour that will be fortified, the average consumption of this flour among the target population. The acceptable range, which accompanies the target quantity of each micronutrient, takes into account factors that can contribute to variations in the results of quantitative analyses. These include varying levels of micronutrients naturally found in the flour, variable distribution of vitamins and minerals within the premix, and varying capacities at the mills to mix premix into the flour.
To give some clarity to what we just talked about, let's briefly look at the wheat flour fortification standards from Kenya.
As we can see in this table, the first column lists the different nutrients which must be present in fortified wheat flour in Kenya: vitamin A, thiamine, riboflavin, niacin, folates, pyridoxine, cobalamin, iron, and zinc. The second column specifies which fortification compounds or fortificants should be used. This is important as some compounds are better absorbed by the human body than others. We can see, for example, that for vitamin A, the fortification compound is vitamin A palmitate. For folates, the fortification compound is folic acid. And for iron, there are actually 2 options: sodium iron EDTA or ferrous fumarate. We can see that the recommended target average at the factory for iron in the form of sodium iron EDTA is 30 plus or minus 10 milligrams per kilogram. This means that the mills that produce fortified wheat flour should have as a target 30 milligrams of iron as sodium iron EDTA added to every kilogram of flour. Because of the plus or minus value of 10 milligrams per kilogram, this means that the acceptable range is 20 to 40 milligrams per kilogram of iron in the form of sodium iron EDTA. In the row above, notice a recommended factory average for total iron. You might be wondering why this is included in the standards. As part of monitoring activities, samples of flour are collected and quantitatively tested in a laboratory. The methods commonly used to determine the amount of each micronutrient in flour samples cannot differentiate between the 2 sources of nutrients in the flour: the natural content of micronutrients in the flour, that is, the intrinsic amount, and the micronutrients added through fortification, the fortificants. Results will therefore be a summation of both natural and added micronutrients, which is why total iron is specified in the standards, followed by Kenyan flour millers. There is currently one exception to the total rule explained in the previous slide. Using specialized equipment, sodium iron EDTA added to flour during fortification can be quantitatively measured separately from the intrinsic iron that is naturally present in the flour. If your country uses sodium iron EDTA as an iron fortificant, and the laboratories have the capacity to quantitatively measure the added sodium iron EDTA, that method is preferable. Since the intrinsic content of micronutrients in flour varies depending on the type of wheat and location grown, measuring the added sodium iron EDTA enables the stakeholders to know for certain if the fortification process is working as intended. Next up, we'll talk about the vitamin and mineral premix. Premix is a blend of vitamins and minerals that are added to flour during the milling process. For flour fortification, the vitamins and minerals are in powder form to facilitate mixing with flour. Common premix vitamins and minerals include iron and 4 B vitamins, folic acid, thiamine, riboflavin, and niacin. This is followed by zinc and other B vitamins, namely vitamins B12 and B6. Rarely, countries will fortify flour with vitamin A or vitamin D. However, these vitamins are better absorbed by the human body when added to a fat-based food, such as milk or oil. As we saw earlier in the course, the World Health Organization published recommendations on wheat and maize flour fortification in 2009. Using the best available evidence, recommendations were issued for the 5 nutrients listed in the first column: iron, folic acid, vitamin B12, vitamin A, and zinc. Your country may choose to include all of those micronutrients, a portion thereof, or even additional micronutrients depending on the nutritional needs of the population. As we saw previously in the course, one of the responsibilities of the Multi-Sector Fortification Alliance might be to determine which nutrients to include in fortified flour. For most micronutrients, a single compound type is recommended. For example, zinc oxide is the form of zinc recommended for use in premix. However, for iron, there are 4 types of compounds recommended for use with low extraction flour: sodium iron EDTA, ferrous sulfate, ferrous fumarate, and electrolytic iron. For high extraction flour, such as whole wheat flour, the only recommended iron compound is sodium iron EDTA. In addition to the vitamins and minerals, premix includes fillers, such as wheat or cornstarch, and a free flow agent, such as tricalcium phosphate, which keeps the premix from clumping. If your country is planning a flour fortification program and has yet to select the nutrients to add to the flour, this book published by the World Health Organization and the Food and Agricultural Organization of the United Nations can be helpful. Specifically, you may want to review Part 3, which is titled Fortificants, Physical Characteristics, Selection, and Use with Specific Food Vehicles. The English version of this book is in the Resources section of this module. Online, it is available in French and Chinese as well. Some people have expressed concern that fortificants might jeopardize the organoleptic or sensory properties of the final flour product. However, given the small amounts of micronutrients added to flour, this concern is rarely realized. For some studies on this topic, see the Resources section of this module.
Premix must be purchased from a reputable company. Reliable quality is critical, as poor quality premix may threaten the success of food fortification programs.
The premix should be homogeneous in nature, that is, have a uniform content. It should flow well to ensure proper dosing and mixing with the flour. Premix should also include vitamins and minerals in the most stable forms possible. In addition, a controlled hygienic premix production environment and durable packaging are required to prevent microbiological contamination or micronutrient degradation. It is recommended that flour mills have relationships with at least 2 premix companies. The potential for competitive pricing increases as more companies bid. Also, if one company has difficulties and cannot fulfill the premix order, premix can still be delivered by another company, and this avoids potential supply interruption. Premix companies must have access to a laboratory that assays the premix. This requirement ensures the safety and quality of the product. Premix from a reputable company is accompanied by a certificate of analysis. This document verifies that the product contains the required micronutrients and confirms that the batch complies with the country's premix specification. The Global Alliance for Improved Nutrition can provide a list of reliable premix companies that have been certified by a third-party source. Their website is gpf.gainhealth.org.
In some countries, premix is categorized as a pharmaceutical due to the high quantity of concentrated micronutrients. If this is the case in your country, premix will undergo a special inspection. To hasten the process, the institution responsible for the quality of imported drugs and pharmaceuticals should do 2 things. One is to evaluate potential suppliers prior to starting the flour fortification program, and 2 is to prepare a nationally approved supplier list.
For the last part of this section, I'd like to introduce you to the topic of pre-blend. Some mills prepare a mixture of flour and premix to improve the distribution of the micronutrients in the flour. This is called a pre-blend. The pre-blend mixture is stored in a similar manner as premix. A feeder is still used to add the pre-blend to the flour stream, but the addition rate will be higher to compensate for the fact that the premix concentration was diluted by the flour. Generally, you should only make enough pre-blend to satisfy 1 to 2 days worth of production. As an example, a miller uses premix with a manufacturer's suggested addition rate of 500 grams per metric ton of flour. To facilitate better integration of the micronutrients into the flour stream, the miller decides to create a pre-blend by diluting 25 kilograms of premix with 100 kilograms of flour from the mill's inventory. Therefore, 20% or 1/5 of the pre-blend is premix. To achieve the target addition rate of 500 grams of premix per metric ton of flour, 2,500 grams of pre-blend would have to be used. Now, moving on to the last portion of this module, laboratories. Laboratories are an essential component of a comprehensive monitoring system. There are 2 primary types of testing that will be done by laboratories: qualitative and quantitative. Each test can be used independently, or they can be used in combination to reduce testing costs, as I will explain shortly. Qualitative testing determines whether flour samples are fortified. These tests give us one of 2 possible responses. Yes, the flour is fortified, or no, the flour is not fortified. Have you ever heard of the iron spot test? It's the most common type of qualitative method used by millers and inspectors in countries that fortify flour. This rapid, simple, and inexpensive test detects the presence of iron fortificants that have been added to flour. For flour fortified with ferrous fumarate, ferrous sulfate, or electrolytic iron, the test uses 3 reagents: potassium thiocyanate or sodium thiocyanate, hydrochloric acid, and hydrogen peroxide. For flour fortified with sodium iron EDTA, hydrogen peroxide is not needed. To conduct the iron spot test, solutions must be made from the reagents. These are then added to a sample of flour using a dropper. After a few minutes, fortified flour will display small red dots. Unfortified flour will not. Directions for the iron spot test are available in the Resources section of this module. This topic will also be expanded upon in the Internal Monitoring module. Qualitative tests, such as the iron spot test, are conducted by both millers and regulatory authorities. These tests are administered in mill laboratories and in government laboratories. There are other qualitative tests, for instance for riboflavin and vitamin A. However, these are not commonly used. They will not be elaborated upon in this course, but more information can be found in the Resources section of this module if you are interested. Now let's shift to quantitative analyses. Quantitative analyses determine the amount of specified micronutrients in a sample of flour or premix. Typically, the content of one or two marker micronutrients, such as iron and folic acid, is tested. Other micronutrients are expected to be proportionate in quantity to the marker nutrient, based on the premix composition. To give an example using flour, if the amount of iron in a sample falls within the range stipulated in the fortification standard, one can assume that the other fortificants are compliant with the standard as well. Please note, for the remainder of the section on quantitative analyses, we will only reference flour samples.
Quantitative methods for flour require sophisticated equipment and careful adherence to testing protocols due to small concentrations of vitamins and minerals in a sample. Because numerous factors can contribute to variations in micronutrient levels among single samples of flour, it is best to run these tests with composite samples instead.
Composite samples are composed of at least 3 single samples of flour. Analysis of composite samples saves time and resources by reducing the analytical burden on laboratories. Given the small amounts of micronutrients that are added to flour, having a composite larger sample also increases the accuracy of the quantitative results. Analysis of the folic acid content in flour is usually done with a method called liquid chromatography mass spectrometry. Iron is usually measured using atomic absorption spectroscopy. Details about quantitative methods for measuring folic acid, iron, and other micronutrients are available in the Resources section of this module. As noted earlier, qualitative and quantitative analyses can be used in combination to reduce testing costs. For example, a government inspector takes 5 samples from a mill warehouse during an inspection visit. An iron spot test is used to determine if the samples are fortified. The results show that one is not. A composite sample is then created from those samples that are fortified. The composite sample is sent to the government laboratory for quantitative analysis. It is less expensive to run the analysis on one composite sample than 4 single samples.
Now that we have finished our brief tangent on the types of testing, let's return to the topic of laboratories.
There are multiple types of laboratories involved with any fortification program, as shown in this diagram. Starting at the bottom of the graph, there are premix companies with their own laboratories. However, when they need to verify premix quality, they generally send samples to an independent third-party laboratory. The other types of laboratories, which we will cover in more detail in a minute, include mill laboratories, central mill laboratories, government laboratories, reference laboratories, and independent third-party laboratories. These days, many modern mills have laboratories. If so, staff, including the quality control manager, might be responsible for collecting flour samples, conducting iron spot tests, checking the premix feed rate, and sending composite samples to technologically advanced laboratories for quantitative analyses. If a company has multiple mills within a country or region, it might support a central laboratory. Representatives from this laboratory will audit the practices of the individual mills within the company. Some are also able to run quantitative analyses on samples of fortified flour. However, that capacity is not essential for three reasons. First, the equipment to quantitatively measure nutrients can be expensive, depending on the nutrient to be analyzed. Second, a strong quality management program at the mill facilitates proper fortification of flour, as we will see in the internal monitoring module. And third, results from an independent third-party laboratory are viewed more favorably by government inspectors and clients. The primary role of the government laboratories is to run qualitative and quantitative tests on flour and premix samples. In the case of external and import monitoring, the government laboratory will generally receive samples of fortified flour that were collected by inspectors from flour mills and border entry points, respectively. Laboratory technicians test these quantitatively for at least one marker nutrient. In the case of commercial monitoring, the government laboratory will generally test single flour samples qualitatively first, then form composite samples from those single samples that tested positive for fortification. Each composite sample is then subjected to a quantitative analysis. Since premix is generally imported, premix samples are typically collected at the border and sent for quantitative analysis. Reference laboratories may be available within a country, but in some instances they are regionally based. They should be able to analyze both flour and premix samples. These laboratories can have various roles. They can conduct quantitative testing of all micronutrients listed in the fortification standard in both flour and premix samples. Oftentimes, government laboratories only have the capacity to test one or two marker nutrients. Reference laboratories may serve as a reference and quality assurance check for other types of laboratories. Finally, these laboratories may verify the quantitative results of flour samples if a dispute arises between a government laboratory and a flour mill. Independent third-party laboratories may be available within a country or a region. They can be government or privately owned. Their main function is to be available to test the quantity of any of the micronutrients that must be added to flour according to the fortification standard. They should be able to conduct these tests in flour and premix. Optimally, a laboratory that conducts quantitative assessments of fortified flour or premix samples should have the capacity to analyze all micronutrients of interest, including marker nutrients. They should be ISO 17025 certified to measure the nutrients of interest in flour or premix. They should have proper storage conditions for flour and premix samples and for chemicals used in the analyses. And they should be able to analyze samples and distribute results in a timely manner. To recap what we've covered in the course so far, you've learned about the importance of flour fortification, the role of a multi-sector alliance in a country's fortification program, how to plan for fortification monitoring, standards, premix, and laboratories. With these foundational modules completed, we will move into the heart of the course, monitoring.